Z is equal to x plus iy in the complex plane. This point has polar coordinate r theta, where x is equal to r cos theta and y is equal to r sin theta. Thus z is equal to x plus iy is equal to r into cos theta plus I sin theta. Clearly r is equal to modulus of z is equal to x square plus y square raised to half, which is the magnitude of the complex number, and theta, if z is equal to 0, is the angle between the positive real axis and the segment from 0 to z, is called the argument of z and denoted by theta is equal to argument of z. We note that the value of the argument of z is not unique. If theta is equal to argument of z, then theta is equal to theta plus 2n pi, where n is an integer, is also argument of z. The value of the argument of z that lies in the range minus pi to plus pi is called the principal value of the argument of z. If z1, z2 are any two non-zero complex number, then argument of z is equal to minus argument of z1 bar closure conjugate. Argument of z1 into z2 is equal to argument of z1 plus argument of z2. Argument of z1 divided by z2 is equal to argument of z1 minus argument of z2. We shall simply state De Moivre's theorem. For any real number n, cos n theta plus I sin n theta is one of the value of cos theta plus I sin theta raised to n. Nth root of complex number. Let z is equal to r cos theta plus I sin theta be a non-zero complex number, then w is equal to omega is equal to p cos omega plus I sin omega is nth root of z. If w raised to n is equal to z, where n is a positive integer, then therefore p raised to n cos psi plus I sin pi raised to n sin psi raised to n is equal to r cos 0 plus I sin 0. P raised to n cos n psi plus I sin psi sin n psi is equal to r cos 0 plus I sin 0. P raised to n is equal to r and n omega is equal to 0 plus 2k pi, where k is an integer. Then thus p is equal to r raised to 1 by n and psi is equal to theta plus 2k pi n divided by n, where k is an integer. However, only the values of k 0, 1, 2 dot n minus 1 will give distinct value of w. Then z has n distinct nth root and they are given by w is equal to r raised to n cos of theta plus 2k pi divided by n plus I sin of theta plus 2k pi divided by n, where k is equal to 0, 1, 2 dot n minus 1. Some topological aspect. Definition: a subset G is subset of R is open if for each Z belongs to S there is an epsilon greater than 0 such that ball around Z with epsilon radius is subset of G. The point Z0 is said to be the interior point of the set S is a subset of R if there exists an epsilon greater than 0 such that ball around Z with epsilon radius is subset of S. Further, interior of S written in interior of S in the set S closure is equal to S complement is equal to intersection of G is open and G is subset of S. The closure of S is subset of R denoted by S closure S bar is the set S closure is equal to intersection of F is a closed and F is a superset of S. The boundary of S denoted by dou s and is defined by dou s is equal to s closure intersection x minus s closure. Further, a subset S is dense if S closure is equal to S. Definition. Now see here, repeat. A matrix space XD is connected if the only subset of X which are both open and closed are X and the empty set. Further, a subset S is subset of X is connected if the matrix space SD is connected. Definition. If G is an open set in R and F from G to R, then F is differentiable at a point A in G if limit as s tends to 0 f of a plus h minus f of a divided by h exists. It is denoted by a dash of a and a called derivatives of f at a. Definition. If f is differentiable on G, then we define f dash from G to R. If f dash is continuous, then we say that f is continuously differentiable. A definition now see here. A differentiable function so that each successive derivative is again differentiable is called infinitely differentiable. Definition. A function f from G to R is analytic if f is continuously differentiable on G. Power series. A series of the form summation of n z minus a raised to n is equal to 0 to infinity, where a1 a2 an are constant is called the power series about a. The geometrical series summation of z raised to n is equal to 0 to infinity is power series about 0 and modulus of z less than 1 summation of z raised to n is equal to 0 to infinity 1 divided by 1 minus z.